So hello everyone. Today in this session I'll tell you all the important things about Doppler effect, especially for competitive exam point of views. So what are the things you should keep in mind which will help you in solving questions? Okay, you very well know what Doppler effect is. We know that whenever there is a relative motion between source and observer, the frequency heard by the observer is different from frequency emitted by the source. This concept is Doppler effect. So here the first important questions are based on what is that frequency heard by the observer. Okay, so which we write it as Fv plus minus Vu divided by V plus minus Vs. Let's quickly define it and then we will see how we use it. F is frequency emitted by the source. This is frequency emitted by source, and F dash is frequency received by the observer. So this is the frequency received by the observer. V is speed of sound and air. Generally the medium is air only or whatever medium. So speed of sound, generally in air. Vu is velocity of observer. So this is velocity of observer, and Vs is velocity of source. Okay. So based on this, most of the questions we can do. First thing is you must be absolutely clear what each term in this expression suggests. And then we will see how we apply this. Now as you can see here I have written plus minus. So next question is what sign to take in what situation. Okay. So here idea is very simple. You can remember in this way. See, if observer and source are moving towards each other, frequency will increase. And since observer value is in the numerator, now if observer is moving towards the source, I must increase the frequency. So therefore I'll use the plus sign. So this I'll use when observer is moving towards source. Now when source moves towards the observer, then also frequency should increase. But this term is in the denominator. Okay. So how it will increase the expression? By taking the negative sign. So this negative sign I'll take when source is moving towards the observer. Okay. And similarly, if observer is moving away from the source, I will take negative sign. And if source is moving away from the observer, I will take the positive sign. Okay. This is the basic way which you can remember this. Now we will see how to use this in different situations. So I hope you are clear with each and every term of this. I am rubbing this now and we will see how we can apply this formula to do a lot of questions, a variety of questions. So let's rub this. Let me give you a situation. Let's say you have this source here. It is moving with Vs and two observers are there. Let's say observer A moving with Va and observer B moving with Vb. Okay. This source emits frequency F. Question is very simple. Find frequency received by A and B. So again here I am writing the formula which I will be using, the same which we have discussed, V plus minus Vu divided by V plus minus Vs. Let's do it for first case. Let's call it as Fa is the frequency received by A. Now here I can say that the original frequency is F. Speed of sound should be given, so if nothing is given we will take it as V. This is speed of sound in air. Observer is moving towards. If observer is moving towards, I use the plus sign. And source is moving away. So if source is moving away, it is decreasing and it is in the denominator. So again I use the plus sign. This is very simple. Frequency received by A. Let's write frequency received by V. Original frequency multiplied by. Now this observer is moving away. So if this observer is moving away, I will write minus. Because of this, frequency should decrease. and this source is moving towards. Towards means I should use negative sign because it is in the denominator. So easily we got these two frequencies. Okay, this is the first simple question. Now let's do the same question with wind. Let's say wind is also present in the question. Initially we assume that this is the speed of sound and there is no wind. So if it is not given, we will not take into consideration. Okay. Now let me write it here. Let's say, so second part will be if wind is present. So if wind is present and let's say direction of wind is in this direction VW. So now what will happen is this V which we write in this expression, this will become V effective and this will be V plus minus VW. That is the only difference. Now if you take positive sign if the signal is in the direction of wind. So for B, signal is rightwards, wind is rightwards. So for B case, I can write for B case, this V effective will be V plus VW. Because here signal is in the direction of wind. And for A, signal is leftwards, wind is rightwards. Okay. So for A, since signal is in the opposite direction, I will write V effective as V minus VW. Okay. So now our Doppler effect formula will become F dash is equal to F. This will be V effective plus minus VO divided by V effective plus minus Vs. Very simple. So only one little change will come into picture due to wind. Again I am repeating, if signal and wind are in same direction, and what will be the signal direction? Very simple, it depends on location of observer and source. So from source to this observer, signal is from left to right and wind is also from left to right. So therefore for B, I have taken V plus VW. Same logic for A, I have taken V minus VW. So this is for the case where wind is given in the question. Many questions it won't be given, so you can just write this as a note. And thereafter we will move to next important concept. So I am rubbing this now. In fact, we can take this example only and ask you another question. Next question is, let's say, find wavelength received by A and B. Find wavelength received by A and B. Okay. So regarding wavelength, first important thing is it does not depend on velocity of observers. Very important concept. Here I am writing this important point. It doesn't depend on velocity of observer. That means it only depends on motion of source. And what is the expression we have? This lambda is equal to V plus minus Vs divided by F. So let's understand this, and then in the same example we will try to find what will be the wavelengths received by A and B. So I'm rubbing this. And wind I will not take in any of these questions now. If it is present, you know what to do. So this is the formula which we have to understand. Lambda is equal to V plus minus Vs divided by F. Let's call it as lambda dash because this is the wavelength received by the observer. Okay. So let me write the meaning of it. This is wavelength received by the observer. Wavelength received by observer. V is obviously speed of sound in air. We very well know it. Vs is velocity of source. So this formula, as we can see, does not include velocity of observer. This is velocity of source. F is original frequency. Frequency emitted by source. And obviously this V is speed of sound in air. Speed of sound in air. So that means if wind is there, this will become V effective. That we very well know how to do. Now let's apply this concept here and let's understand when to use positive sign, when to use negative sign. Okay. So here you can remember one other thing automatically you'll remember. Let's say I remember this plus sign. So plus sign I will use when source is moving away from the observer. So here I can write this positive sign I will use when source is moving away from observer. Source is moving away from the observer. So when it is moving towards the observer, then I will use this negative sign. Okay. So in this case, source is moving away. So if source is moving away, I will use positive sign. If source is moving towards, I will use negative sign. Now let's apply this concept to the example which we have taken. Okay. So I have rubbed, I think, the B part. Let me write it again. So this I am rubbing. So this is your source, and this source is moving with velocity Vs, and there is this another person, and another person V is moving with velocity Vp. This is our example. Now I want to find wavelength received by A. Let's say that is lambda A. Now with respect to lambda A, source is moving away. So if source is moving away, I will take the plus sign. Plus Vs by F. F is the frequency emitted by source, very simple. Lambda B is wavelength received by B. With respect to B, the source is moving towards. Moving towards means I will use negative sign. So V minus Vs divided by F. Very simple thing. Here it has nothing to do with. Okay. So VA and VB are useless here. It may be 0. Lambda will not depend on it. So these are nothing but wavelengths received by A and B. It only depends on motion of source. So if suppose Vs is 0, that means lambda will be as it is. It will remain same, there won't be any change. But if source is moving, yes, this will change, and this is the way it will change. Now remember, all these velocities are along the line joining source and observer. So if you have a velocity which is not along the line joining source and observer, then you have to take a component. Okay, right. So that you should keep in mind. Here I can write one note. In both these formulas, in all these formulas, this Vs and Vo, these are velocities along the line joining. Along the line joining source and observer. So suppose, for example, this is observer, this is source, and let's say source is moving with the VO at an angle theta. And let's say the source is moving Vs at an angle sub alpha. It emits frequency F. Now I ask you what will be F dash. So as I told you here, we will take velocities along the line joining S and O. So that means which velocity will be useful? Only this velocity. VO cos theta and Vs cos alpha. Now directly we can apply the Doppler effect formula, shift formula. What it will be? V. Observer is moving towards, so plus VO cos theta. Divide by source is moving towards, so V minus Vs cos alpha. Okay. So this you can just write as a note. If velocities are not along the line joining O and S, that's what we do. Okay. One more example I'll give you based on this. Let's say you have this wall and this is a moving wall. So it is moving with, let's say, velocity U. And this is the source, it is moving with velocity 2 units. And speed of sound in air is given as 5u. For simplicity, these values I have given. This source emits frequency F. So question is find wavelength incident and reflected wave. So there will be one wave which will be incident, the other wave which will be reflected. We have to find what will be the wavelength of incident and reflected. Incident wave is very simple. This will be the source. So this is your source. It is moving with 2u, and you can assume this is the observer. Let's say this is the observer. So now directly you can apply this lambda of incident. I am writing lambda I. This will be what? Let me write it there instead of this. So look carefully here and remember the formula which I just told you in the previous discussion. So lambda I, it only depends on velocity of source, and here source is moving towards. If source is moving towards, I have to use negative sign, yes or no? So minus Vs by F. Okay. And here values are given. What are the values given? This V is given as 5u. So this will be 5u minus, and Vs is given as 2u divided by F. So this will be your incident wavelength. Now reflected wavelength, for reflected wavelength, this will become the source now. So first of all, here we have to find what is the frequency received, because we know that on reflection frequency will not change. So I need to find this f dash. This is frequency received or frequency reflected. And f dash we very well know how to find. Doppler shift formula I'll use, which is original frequency, source is moving towards, observer is moving away. So V minus U divided by, this is moving towards. So moving towards means V minus 2U. So f dash I know. Now this will be the frequency which will be reflected, yes or no? And this wall is reflecting the frequency, so this wall will become the source now, which is moving with velocity u. Okay, and it is traveling leftward, so you may say that this source, now it becomes the observer. Which was the source, now it will become the observer. Anyways, its velocity will not matter. So what will be this lambda? Let's call it as lambda of reflected wave. Source velocity, you can see that it is moving away from the signal. Signal is moving left, source is moving right. So if it is moving away, we will take positive. So this will be V. V is 5u plus, this is u, velocity of source. I am taking plus because signal and source are moving in opposite direction. Divide by f dash. This is the frequency emitted. So this f dash you can write it here, and you will get wavelength of the reflected wave. Okay, right. So if your basics are clear, any question of Doppler effect you can do it based on this discussion. Right. Thank you.